All right, guys, we're going to jump into, we're still talking about slope, like I just told you guys. We're still talking about slope, but we're also going to jump into what's called direct variation. Okay, now, when you guys walked in, I told you to get two separate pieces of paper, did you? No, you did not. Okay, she got one of them. But there are two, we're going to pretty much go through two different lessons, but the reason we're going to do two of them is because they're pretty much the same information. Okay, now the first part of this that we're going to do today is we're going to talk about finding slope in word problems. Okay, slope in word problems. So I'm not, there's only like 3 or 4 examples, and then we're going to jump into direct variation. This might take a little bit today. Okay, like I told you guys, this one could be a little bit longer. I apologize, but some days it be like that. Okay, that's just the way it goes. All right, here we go. Bella's Pizza Shop charges $4.50 for a small pizza. People are like, man, when am I ever going to do algebra in real life? Let's check this out. Here in a second, I'm going to ask you to solve this without my help. By the way, I'm not even going to walk you through it. Bella charges $4.50 for a small pizza, $7 for medium pizza, and $9 for a large pizza. Toppings cost extra depending on the size of the pizza that you order. Bruce ordered a large pizza with 3 toppings that cost a total of $12.60. What is the cost per number of toppings for a large pizza? Okay, so here's what I want you to do. You guys have neighbors, right? What I want you to do is try to figure out how much it is per topping. I'm not going to help you. I want you to tell me how you would figure out how much it is per topping. Ready? Go. All right. What'd you get? How much is it per topping? I heard 1.2 and I heard $1.20. Okay, it is $1.20. Now let me ask you this: how did you guys do that? $1.20 per what? Per topping. Okay. How did you figure that out? Okay, hold on. You took the $12.66 and you subtracted the $9 for the pizza, right? And so you got $3.60, correct? And then you did what? You divided by 3. Why divided by 3? Because there's 3 toppings. Can I show you something pretty crazy? What you just did was algebra. Let me show you. Here's your equation. If I took this equation, okay, and I had 3 toppings for X amount of price, right? Plus the $9 pizza equals $12.60. What you just did was a 2-step equation. What's the first thing I would do to solve for X here? I would subtract 9 from both sides, which is exactly what you just did, right? And then we would drop that 3X down here, and then what would I do? Divide by 3. You just solved a 2-step equation to figure out the price of the pizzas without even realizing you just did a 2-step equation. Think about it. You subtracted 9, and then you divided by 3 to figure out the price. You see what I'm saying? Now, I know that you're not going to be like, well, if I want to figure out the price, I need to set up a 2-step equation. I get that. I 100% get that. You're not going to do that in real life. That's understandable. Okay, but I've told you guys several times that what we're doing in class is we're trying to set you up to learn how to use your brain in real life. Correct? That's what we're doing. We're teaching you how to think for yourselves. Majority of the stuff that you use in high school, you're not going to use in real life. You're not going to. The majority of the stuff that you learn in college, unless you specialize in something, you're not going to remember what you took in your college English class. You're not going to learn you're not going to remember your geography class or your science class, those biology, unless you're like going into nursing or doctor or whatever. You're not going to remember that stuff. Okay? But what they're doing is they're teaching you how to think. That's the point of school. And what you just did was a 2-step equation. Does that make sense? Okay? Finding slope. The slope is, well, if I rewrote the equation, I can rewrite it like this. The cost equals $1.20 for the number of toppings plus a $9 pizza. Wouldn't that be it? $9 plus $1.20 per topping is going to give me my total cost. There's my graph. Fair? All right, here we go. Let's go to another one. This one, absolutely nobody got this one right yesterday. Nobody. Everybody is, here in a second, you guys are going to stare at me because you're going to be a little bit lost. A maintenance crew is paving a road in 7-hour shifts. After 10 shifts, 1.25 miles of road have been paved. After 45 shifts, there are 5.625 miles of road. At what rate is the maintenance crew paving the roads? So they want to know how much it is for what? Per what? Per shift. You think you can figure that out? Do me a favor. I'm going to give you guys a second to think about it, and I want you to try to figure this out. Fair? Nobody was able to do this yesterday. Literally, everybody gave me the same look that you're giving me right now. And everybody just kind of gave up on it. Just trust it. Let's see if you can figure this out. Ready? Go. All right, we got this thing figured out yet? Do we have any answers? What'd you guys get? Are you still doing it? Okay. Now, what you have is you have 10 shifts. We're doing it per shift, right? Hold on. Look, everybody good? Per shift. So the shift is actually going to be on bottom. Yes? Is everybody yes? Which question? Think you got it?
So per shift is 0.125 miles.
Yeah, I think that's what he said. Yeah. How many of you said 0.125? Did you guys get it? Okay. It is 0.125. Let's figure this out. How much is it? It's 1.25 per 10 shifts, right? All you got to do is divide. How many of you did that? How many of you are like, oh, just divide? Yeah, it's not that big of a deal. After 45 shifts, it is 5.625. If you divide by 10, that slides over, doesn't it? If you divide by 10. You guys remember that trick? You divide by 10, you just move the decimal. 0.125. What is 5.625 divided by 45? Is it the same thing?
Yeah.
Did you check it? Yeah. Okay, cool. It's the same answer. Pretty easy, right? Write down the word per somewhere. Per. 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 Yeah, that was weird. Sorry. I take that back. Per. Do what? That's all right. Digital footprint. I thought about doing a live today. That would have been fun. To both my followers. Shout out to my stepdad. Okay. I know I'm kind of joking around, but I promise you this dude is going to watch it. He's going to watch. So his name's Ron. What's up, Ron?
Ron?
I was going to try to say something funny. I got nothing. I got nothing. All right, here we go. All right, is everybody good? What were we doing? What? Oh, per. Per, thank you. Per is slope. Per is slope. There it is. Per is slope. Thank you for getting me back on track. Per is slope. Squirrel, shiny. All right. Everybody good? All right, let's go to the next one. Let's do one more. Uno más, for those of you that are German. All right, here we go. Melanie is baking breakfast rolls for Bandcamp fundraiser. She bakes 15 dozen breakfast rolls in 3 hours. After 8 hours, she's baked 5 dozen breakfast rolls. At what rate does Melanie bake breakfast rolls each what? Each hour. So we're trying to find the number of dozen of rolls. Say it. Per hour. There it is. Per hour. We're looking for that slope. Go. Pause. All right, so what do we get? 5 what? Tell me how you did it. 15 divided by 3, and also what? 40 divided by 8. Do these have the same rate? Yeah, they do. They have the same rate. We're going to talk about that here in a minute. We're going to talk about direct variation. Okay? Good. So we're kind of understanding this. Do I need to go through this anymore? You guys kind of understanding this? 1 to 5. Show me how we're doing. Doing a good job. Doing a good job. You're doing a good job. I see a lot of 5s. 1 to 5. Okay. 4s. Okay. Perfect. All right. Let's go to direct variation. Here we go. You guys have your notes out? Okay. A couple of rules I want to talk about. Now, direct variation is, I actually think it's easier than y. You guys know y equals mx plus b, right? I think direct variation is actually easier than y equals mx plus b. Okay, it's 100% easier. And we're going to talk about what it means here in just a second, okay? Give me fractions that equal 1/2. Give me fractions, okay, you have 1/2. Give me another fraction that equals 1/2. 2/4, right? Give me another one. 8 over 16. What else? 3 over 6. What else? 10 over 20. Okay, let me stop you. Whoop, that's 10 over 10. 10 over 20. If I was to reduce every one of those into a decimal, it would be 0.5. Would you agree? Yes, I see a lot of nodding. Everybody's at 0.5. Okay, they directly vary with each other. Now, here's another way to check it. What's 2 times 2? What's 4 times 1? When you cross multiply, you should get the same answers. Okay, like what is 4 times 8? Nope. 32. What's 16 times 2? 32. Okay. What is 6 times 10? 60. What's 3 times 20?
60.
You see what I'm saying? They all kind of work together, okay? Direct variation. If I put another number into that, it's going to be an issue. So let me explain to you what direct variation is, okay? There are a couple of rules. Number one, direct variation. You might want to write this down on your notes, just on the top of your worksheet that I gave you. Direct variation. Number one, it has to be linear. Bless you. This is not on your notes. This is extra. You don't have to pay me extra for this. I'm going to give you this one for free. Okay? You don't have to pay me extra. Okay? Number one, it's linear. Okay? Number two, it always goes through the origin. What is the origin?
0.
The origin is 0, 0. Every time I draw that, it looks like the top half of a face. I always think that when I see it. Like an alien. Little alien face. Okay. All right. Take me to your leader. Okay. Everybody good? So this one they've got circled. If you notice direct variation, this one does work, okay? This one does go through the origin. Okay, this one doesn't, this one doesn't, this one doesn't, and so on, okay? All right, let's talk about direct variation. Direct variation is a specific relationship in which there is a constant ratio. There is a constant ratio, which is y over x, between all ordered pairs. Direct variations are written in the equation, this right here. Why? Please don't ask me why they do this, okay? I don't know the answer. If somebody knows the answer to this, please comment below. Okay, please. I don't know. All right. Y equals kx, which sounds a whole lot like what? What's the slope-intercept equation? Y equals mx plus b. Please don't ask me why they changed it from m to k. I really don't know. I wish I had an answer, okay? That's probably something I can Google. I'm lazy, okay? I just don't want to. Okay, but it's y equals kx, okay? K is pretty much your slope, or your what we call your constant of variation, okay? It's the same thing as your slope. It all kind of works together. That's why we're kind of doing this right after slope, because it's kind of the same thing. Everybody with me on this?
Yeah.
So let's check this out. So if I'm finding the constant, here we go, finding the constant. Which, okay, if we're finding the constant, why did they use the letter K? Why couldn't they use C? Okay, whatever. All right, here we go. 4 over 1. Check this out. 4 over 1. What's this fraction? What is 4 divided by 1? 4. What's 8 divided by 2? 4. What is 3 divided by 12? Okay, so do you see a pattern here? So what is my constant of variation? 4. You guys do that? Identify the constant, and then write the equation. So here we go. Y equals 4x. Basically, you plug a number in for x, you multiply it times 4, that's going to give you the y every single time. Okay? It is a constant variation. It is a constant. Okay? All right. Now, some of them aren't going to be that clear cut. So let's talk about the second one. What's my x? What's my y? Y is 3. What's my x? What is 3 over negative 6? Negative what? You have a calculator, right? Alpha y equals? You guys remember alpha y equals 1 on your calculator? Go ahead and put it in. That's hot. What is 3? Negative 1/2. Here we go. Negative 1/2. Isn't 3 over 6 a half? Yes? Okay. Same thing. 2 over negative 4. What is that? Same thing. Negative 1/2. Then you got 0, 0. Go ahead and open that door, please. Then we've got 0, 0. 0, 0, we don't have to put that in a fraction because I told you that it was always going to go through your origin, right? Okay. Hang on one second, guys. I got visitors. You guys want to say hi to my videos?
Oh, hello.
Say hi. Yeah. Yeah, we're recording. We're YouTubing. Huh? I know. I record every one of my lessons now. So you want to say hi? Yeah, I have a YouTube channel.
Hi, YouTube.
Yeah, there.
What's it called? I'm gonna subscribe.
At Coach Moy Algebra.
Oh, we'll subscribe.
I do every one of my lessons.
Really?
Yeah, I really do.
Wow.
Why not? Okay. It's an M. It's not no. Okay, it's an M. See you guys. Bye YouTube. Okay, cool. Yeah, I could have paused, but I just didn't want to. All right, here we go. So what's my constant, guys? What do you guys got? Y equals negative 1/2 what? X. It's always, the constant always goes in front of the X. kind of like your slope. Everybody good? Okay, do me a favor. Do number 3 and number 4. Remember the y goes on top. Go. All right, let's get refocused on this. All right. Number 3, what'd you get? 2/3. Y equals what? 2 over 3. If you put all these, -8 over -12, what did two negatives make? Here's the reduced version, by the way. It's down there on the bottom, right? 2/3. It's actually the very last one. What'd you get for number 4? Y equals what? -3x. Perfect. If you 12 over -4, 3 over -1, -9 over 3, -15 over 5. Now, one thing I do want to point out on this, did you notice how the negative switched on one of them? Did you guys see that? Negative is on bottom, wait a minute. Bottom, top. Doesn't matter. If one of them is negative, the whole thing is a negative, okay? Keep that in mind. All right, we good? All right, now we've talked about it from a table and points. Let's talk about it from an equation. Okay, here we go. Number 5, does that look like direct variation? Yes. What is the constant? What? Yes, it is. The answer is 3. Yes, it's 3. Yes, it's 3. 3 is your constant. Number 6, yes or no? Look at it. Yes. -4 over what? -4 over 5. Number 7, yes or no? No, it is not. Okay? No, it is not. 7 is not. Number 8. Can I put it in y equals? Can I do it? How? Divide by what? Divide by 2, right? So if I divide by 2, watch what happens. I divide by 2, I get y equals 5 over 2x, right? Now does it work? Yes, it does. What is it? 5 over 2. 5 over 2 is my constant. If you can put it in y equals kx form, you're good. Okay, so here's what I want you to do with the rest of them. I want you to see if you can get it. I'm just going to give you a quick couple minutes to work through that. Go. Guys, just remember, if you can put it in y equals something x, y equals 2x, y equals a fraction of x, y equals x, y equals something x, but that's it. There can't be anything else, then it is direct variation, okay? Then it is direct. So what is 9, yes or no? No, it is not. No, because of that -4, it is not, and I'm going to show you why here in just a minute, okay? I will show you why in just a second. What about 10? Yes, it is. What is the constant? -1. It is -1. There's a negative on the front, okay? Number 11. Yes. So what is it? Yes. What's the constant? 1/2. I got to divide by 2. I got to move the 2 over, right? Because I want to put it in y equals. Yes, I got to get rid of that 2. I've got to divide by 2. And if there's no number in front of a letter, what's the number? 1. So if I have this, look, if I have 2y equals x, and I'm trying to move it, I divide by 2, divide by 2. Remember, there's a 1 there. So now it's a 1/2. Everybody good? Yes? All right, number 12, yes or no? No. No. Because I can't just put it in y equals something x and be done. This +6 is going to mess everything up. The +6 is going to mess everything up. What about number 13? Yes. I can actually move this 5x to the other side and it just becomes y equals -5x. The 0 is there just because there's nothing else over there. You got to put something there. But once I put the -5x on that side, then we're good. Yes? Now, let me show you why you don't want these numbers on the end. Okay, can I show you this? If I have this, this has nothing to do with the ones we just had, okay? If I have y equals 2x, correct? If I put x, let's say x and then y. Okay, let's find some numbers. Let's put 1 in for x. What's 2 times 1? What's 2 times 1? 2, cool. Let's put 2 in there. What's 2 times 2? 4. Let's put, give me another number. That's boring. 9. What's 2 times 9? 18. All of these are going to reduce down to what? 2. Agreed? And if I made those all fractions, they would all be the whole number of 2. Is everybody with me? They're constant. Oh, stick with me on, hey, stick with me. They're constant. Let me show you why it doesn't work if I put a number on the end. Let's say I put a +1 on the end. Just a +1. Okay? Nothing crazy. Just +1. Okay? Let's do the same numbers. What's 2 times 1? +1. 3. Okay? What's 2 times 2? 4 + 1. 5. What is 9 times 2? 18 + 1. 19. Do me a favor. Change these. This one we know this one's going to be 3. What is 5 divided by 2? But do it in your calculator just real quick. 5 divided by 2. 2.5. Do me a favor. What is 19 divided by 9? 2.1 extended. Do they match?
No.
They're not constant. That's why you can't have a number on the end. It's got to be just y equals something x. I see people nodding. Does that make sense? It's got to be just that, and that's why it has to just go through the origin. Fair? Now, I know you don't have anything on the back, but go ahead and flip it over. All right, let's talk about a couple more things. You don't have to draw these, but I'm gonna cover a couple quick things. What did I tell you that I had to go through, guys? It has to go through the origin, and it has to be linear. Is this good or is it bad? This one, so yes. And then it says identify the constant of variation, which is another fancy way of saying what? Say it. Slope. Point. Go up. 1, 2, 3, and over how many? 3 over 2. We're done. Just find the slope. If it asks for the constant of variation, just find 2 points and just count rise over run. Okay? Number 15. It's already written on there. 15. Does that one work? No, it does not. Okay? That one does not because it does not go through the what? Origin. If I wanted to write this equation, by the way, here's what the equation would be. Y equals, this crosses at 1, 2, 3. This crosses at +4, and my slope is down 1 over 2. That's the equation. That +4 on the end messes everything up. Okay? All right. Number 16. Yes or no?
Yeah.
Yes, that one's good. Positive or negative, by the way?
Negative.
That one's negative. Down 1 over 4. So -1/4. Okay? What about number 17? Does it go through the origin? Is it linear? Then we're good. That's all it is. That's really all it is. Everybody fair? Everybody's good? Hello? If you're going to walk behind me, you at least wave to the camera.
Hey guys.
Dude, are you wearing a Dale Murphy jersey?
No, my dad just loves the Braves.
No, turn around. I want to see.
I don't know if
No.
that's it.
Dude, that is Dale Murphy. You got to do some research. That was a player. Okay. Baseball. Okay. All right, let's do this. You guys write down the first one, just like you see it. 2 -4, and then you have -6y. Do you guys remember doing proportions? Yeah, we're going to solve the missing number. Yes. When I was in Atlanta, we actually went to Dale Murphy's little bar and grill before we went to the game. He was a good ball player for the Braves. Oh, this was back in the early 90s, I think. Maybe late 80s. He was really, really good. All right. Set up a proportion. What letter goes on top again, guys? Y. So I've got -4 over 2 equals y over -6. Yes? These go on top. Yes? Everybody good? All we're going to do is cross multiply and divide. That's all we're doing. What is 2 times y? 2y. What is -4 times -6? Positive 24, because 2 negatives when you multiply it equals a positive. And now I just divide by 2. Cross multiply and then divide. My missing number is a 12. My missing number is a 12. Do you guys remember doing that? Setting up proportions. Okay. I really like proportions. I really, really do. Like if I wanted to, I can go out. I need to figure out how tall the flagpole is at the softball field. You know I can do that measuring proportions. I can measure my height and the shadow on the ground. And then I can measure the shadow of the ground on the flagpole of the softball field, and it'll tell me how tall the flagpole is. proportions. It's actually kind of cool. All right, here's what I want you to do. Let's work through, hey, let's just do number 19 and 20. Let's go 19 and 21. Fair? 19, 21, I want you to do that on your own, and then we're going to be done. I'll give you guys a break, okay? Stay with me. We're almost done. Stay with me, all right? Let me give you a couple minutes. All right. What is 16 times x? 16x. What is 4 times 24? You should have done that in your calculator. 96. And then you divide by 16. Yes? What does x equal? Done. Those, if you graph those 2 points, the 2 points will cross at the origin. Okay. All right. Last one. Here we go. Negative 16 over x. And then we've got 24 over 6, right? This goes on top. This goes on top. Okay. What is 24 times x? 24x. What is 6 times 16? Negative what? 96. Yeah, same numbers again. Divide by 24. Divide by 24. What'd you get? Negative 4. There's my answer. You guys good? Can you guys see how this kind of ties into slope? It's kind of the same information, right? We're not going to assess over this until you guys get back from your break, okay? What I'm going to do now is I'm going to give you a little bit of a break, okay? Then we're going to do a quick assignment. It won't take very long, and then you're going to take a quick check over slope and direct variation. Pretty easy day. Cool? All right. Click like, subscribe, share with your friends.